Okay, so we're gonna do this broken neutral circuit here, and what we gotta solve for is, oops. What we gotta solve here is the voltage across the break, so the voltage right here across our neutral, as well as the voltage drop that's gonna be across the 75 ohm resistor. So the first thing we gotta do is, because we no longer have this neutral in place, we are now dealing with, between line 1 and line 2 here, 230 volts. So the 230 volts is split between these two resistors here. But as you know, we can, when we simplify a series circuit, we can simply add these two together, the 50 and the 75, which gives us 125 ohms. And that's going to be our total resistance. And we got our total voltage of 230 volts. So now, because we know the totals, we can figure out the current by using Ohm's law. I total equals E total over R total. That's going to give us 230 divided by 125. So a current of 1.84 amps. Alright, so now we can assume that that current is going through this resistor here. And in a series circuit, I total is going to equal I1, which equals I2. So all our currents are going to be the same going through each of these loads in the circuit here. So through this resistor is going to be a current of 1.84 amps, as well as this resistor here. Knowing that those currents go through those particular resistances now, we can find out the individual voltage drops going through each. So we don't so if we're looking for voltage, now we use Ohm's law again, but we're going to be using it in a transposed way. So voltage is going to be equal to current times resistance. So 50 times 1.84 equals 92 volts. And 75 times 1.84 is going to give us 138 volts. Okay, so now we found out that the voltage across 75 ohm resistor is 138. So we can enter that in here. The last thing we need to figure out is the voltage across this break. So between this point here and this point here is 115 volts. Then our voltage drops 92 volts here. So between this point and this point is going to be simply the difference between 115 volts and 92 volts. So remember, from this point here to this point here has to equal 115. And if we have 92 dropped here, well, we still need to account for the difference between 115 and 92 to satisfy Kirchhoff's voltage law. So 115 minus 92 is 23 volts across our break. Now, we can look at it the other way as well. From this point here to this point here, there's a voltage source of 115 volts. Now we have a drop of 138 here, but we know that the 115 needs to equal our 115 source needs to equal our drops. So we have a drop of 138 here But in this case, going the other way, we have a rise of 23, which brings us to 115. So the difference between 138 volts and 23 volts is, again, going to be 115 volts, which means we have satisfied Kirchhoff's voltage law. So the voltage break, no matter what way you're looking at it, from this conductor to the neutral or this conductor to the neutral, is going to be 23 volts. Again, you just got to look at the difference of the voltage drop on load and the source voltage between the neutral and either line 1 or line 2.